Good morning, Cześć from Poland. I'm recording this third time. I was trying 2 live streams. It was either disconnected, it was cutted, or I was talking too much not relevant things. So this time it's not live. I will try how it works. What was the agenda, and we see that there is no drone. Actually, drone is there. It is screwed and glue with hot glue. And actually, what I can say and show, so there is access to radio binding. Anyway, it is currently binded, but there is access to microcontroller USB. Access to the reset from the bottom. I was trying to find the hose, and alignment allowed to have the access. So the other access is to the battery plug-in, and the other things is access to program BLHeli ESC. So electronic speed controller to control the motors. And that's it. And for programming, there is one more microcontroller, and this is currently connected with IMU, and one more wire is connected for the motor to the logic analyzer. So we will see the protocols that are used and allow to use the motors. So mainly drones use a pulse width modulation with one shot. So we have, for example, one shot 125 the width of the pulse to 250 microseconds. And this is also the resolution. It is good to mention, actually, and this is the note to you and to myself. What are the possibilities? So having 100 megahertz microcontroller, so you have 100 hertz per in the unit. Okay, so let's say if we have 125, so if we multiply by 100, so we have the starting signal for arming, and for the definition, so half of the pulse is the beginning, and rest is the maximum speed, let's say. So that's let's say less frequent modulation, 125 to 250 get good resolution, because the other one is 42 to 84, and if you multiply 42 by 100, so we have 4200, and if we have the clock 150, like in Nucleo G431, so we are multiplying by 15, so that's why it was 6,300 to 12,600. So that's like the relation is between the fastest MCU. It gives actually more detailed and better resolution for the signal to control it as well. And another two very popular are multi-shot, 5 microseconds to 25 microseconds. So it's like 500 to 2050 with 100 megahertz. So 2000 units of resolution for that one. And the other one is D-shot, and this is digital coding with CRC, and we are sending, let's say, zeros and ones, and 0 is half of the 1, and actually it used the algorithm to provide the values, and because it's digital, so and there are different versions, so it might be very fast, much faster actually than the loop for IMU. So this resolution, there are trade-offs as well, because we can update motors very often, but we are getting the inputs for IMU much slower. So there should be some ratio actually, and best would be actually 1:1. So same speed to control much more dynamically. And yeah, that was the note about that. In this video actually we will see a oneshot 42. I'm using that one. It is not D-shot, which is the most modern one. Maybe there are some other, but one-shots, multi-shot and D-shot are most common. And what I need to mention also, there was one question, and I met some most questions were from Lee. I was showing the checking the thrust with the weight, and yeah, actually, because I'm recording the third time, it's it allowed to think 3 times about that. So yeah, I decided after two issues while doing the live to actually record that and well keep that. So the question was about the thrust and the weight. So I was measuring the weight that is, let's say, goes from the air below the propellers and motors, and I was checking with the weight what is the heavy, how heavy is the air there actually. And I made the note to mention also, and to better understand what is the thrust. And the equation for thrust is velocity times change of mass divided by change in time. Okay, this is from the physics, from equations, and if we decompose and we try to find the units. And why I'm mentioning about what is what, because yeah, we are trying to model and to use the model in the real scenarios. And actually, if we have drawn car or house, and we are trying to do change the parameters of some physical properties. Let's say in that case we want to add the thrust to the drone, so we need to know and describe actually the system, and to have information about what units use the parameters of the system. So like temperature, pressure, the force. For drone we will be thinking about the forces, and thrust is one of those forces. For regular plane, I would say the thrust is in that direction, and the other 3 forces that are there. So there is a lift allowed to move up, and the opposite force is the weight. So lift is fighting the weight to keep the plane in steady state, and the thrust allowed for movement. And because there is movement, there are the particles, so we have the opposite force of the drag, which it's much lower than the thrust. That's why we are moving the forward. And if the lift is bigger than the weight, so the plane can can fly up. The same will be for the drone, and together with thrust and the lift, the direction of both forces is same. So in the hover and actually, well, the hover is steady state between the lift and weight, but to fly up, the lift should be bigger than the weight, and there is ratio between the thrust and the weight. So the forces, so it is like mass times acceleration up, and the weight is mass times gravity acceleration down. I put some notes actually on the paper, and I'm trying to decode that as well. So the masses are cutted, so we have acceleration divided by gravity acceleration, and of course if acceleration up is bigger than the gravity, so it's more than 1, I would say, because the steady state it will be like 1, so A times G, so we are just fighting the weight. Okay, and having the equation again for the thrust, not mass times acceleration or the gravity, by thrust like the velocity times change of mass divided by change in time. So from the velocity the units are meters per second, and from other part of equation change of mass time change in time is kg per second, and we having the Newton, which is kg times meters per second square. Okay, the units are imported for the systems that we are working, and the system have inputs and outputs. In our case, our inputs are the transmitter and radio signals, and of course the IMU information for the orientation, for the acceleration, for the angles. So angles, we have degrees or radians, so we are working with the units, so we need to know what units, and we have the time, so usually the seconds or microseconds, so we should properly compose the equations to use values with the units actually, to better understand that as well. And what is the definition of the Newton and the force? So it's the force that is put to the body of 1 kg, so 1 Newton is the force that are on the body of 1 kg to accelerate that body 1 meter per second square. So this is the definition of 1 Newton. So 1 Newton is 1 kg times 1 meter per second square. Okay, so also what we can say about the acceleration. So acceleration is 1 meter per second. So every second the change in speed is 1 meter per second. So we are adding every second 1 meter per second. So this is the constant acceleration, or that way actually. Okay, and there is also relation between the force and the work or energy, and between the work or energy and the power, so between the joules and the watts. I won't be saying that I was saying in previous unsuccessful 2 live streams today, and we are working on the forces currently. The power is for the battery maybe, but yeah, maybe for house will be will be good to talk about the joules and the watts. In that case, we will focus on the forces. So newtons, kgs, meters, seconds, meters per second square, meter per second, and this is the answer to Lee about the mass, and yeah, again the pressure, so the force that's working on some area. Okay, that can be also good to think and to have this intuition about the physical units and yeah, mainly that. Actually, the testing Nucleo is currently powered. I can actually, yeah, okay, I will just start the signal checks and we'll reset, so we have it again. Okay, and what is about 42 one-shot 42? So if we change the resolution, so we are there, we see that half of the width is 42 microseconds and the wall pulse is 84 microseconds. So we are arming at that stage, and if we are increasing the width of the signal, so we are going to the full speed of the motor. Okay, I've answered Tuli. I've shown one-shot 42 with the ESC. Okay, so it's running. We see the resolution, and the D-shot. After some time, maybe we will try with D-shot, but it's more important to make it fighting the lift, causing having the thrust, not fighting the lift, taking the lift and fighting the weight. Yeah, so we have positive acceleration that is increasing and negative acceleration also that is decreasing if we are landing. So weight, lift, and thrust. Okay, and again the access to binding, to programming debugging, to the power, to the ESC programming with BL-Heli configurator for Linux. It's good to know that there is tool for Linux is BL-Heli configurator. Yeah, and the forces for newtons, kg times acceleration, so mass times acceleration, so kg times meters per second, so second square. Okay, good notes. Let's stop this crazy signal, and you see it's not perfect maybe, but it is decoded correctly. All right, cheers.